Hi, my name is Evan Greenspan and I work as a senior GIS analyst for California Department of Fish and Wildlife. CDFW has been mapping ungulate migrations across California, and we'd like to share with you some of our promising results. California is home to a number of ungulates, including mule deer, elk, pronghorn, and bighorn sheep. Many ungulate herds in California are migratory and inherently need large landscapes to persist due to the vast distances covered during migration to access resources and avoid harsh winter conditions. This makes migratory herds particularly vulnerable to habitat loss and fragmentation. Transportation infrastructure is a key source of fragmentation, inhibiting ungulate migratory animal movements. Preserving connectivity between habitat patches is therefore crucial to conserve these charismatic species and to facilitate their movement across the landscape. To improve the quality of ungulate winter range habitats and migration corridors, CDFW are undertaking efforts to collect fine-scale movement data via GPS collaring projects for herds across the state. Analytical techniques allow for population-level corridors, stopovers, and winter range habitats to be visualized and prioritized for conservation and management action. As a brief methods overview, GPS collar data are cleaned per herd and bad locational fixes are removed. The cleaned fixes, as seen here for a single herd on the map, including location, date, time, and average location error, are grouped by unique individual ungulate identifiers and used as inputs in the migration mapper software to construct Brownian bridge movement models. As an example, the Jawbone Ridge mule deer herd seen here contained more than 290,000 points from 83 collared deer and 243 migration sequences, which include one spring and one fall migration per year. Individual ungulate migration sequences are identified using net squared displacement graphs seen on your right. Fixes that fall within migration sequences are extracted and converted to lines, as seen in the map on your left. Brownian bridge movement models are produced at a spatial resolution of 50 meters using a sequential fix interval of less than 8 hours and migration sequences identified by net squared displacement graphs. Fixes between the end date of fall migration and the start date of spring migration per individual are designated for winter range analyses. Final products include population-level corridors, stopovers, and winter range. Corridors and stopovers are prioritized based on the number of animals in the sample moving through a particular area. Corridors are visualized based on deer use per cell, separated into a 3-tier corridor classification, with more than one deer, 10% of the sample, and 20% of the sample representing migration corridors, medium use corridors, and high use corridors respectively. Stopovers are calculated as the top 10% of the population level utilization distribution during migrations and can be interpreted as high-use areas. Winter range is visualized as the 50th percentile contour of the winter range population level utilization distribution. To visualize the products being produced, a story map has been created for your viewing pleasure. This can be found at the link at the end of the presentation or by searching for ungulate corridors across California in ArcGIS Online. What you are seeing now is taken from that story map. So far, 15 herds have been analyzed with many more GPS projects in progress. The story map will guide you through the 15 herds, showing a map, a short summary, and important stats for each herd. For example, the Jawbone Ridge mule deer herd final project is seen on your screen now. We encourage you to explore the story map as a part of this multimedia presentation. Thank you very much.